So this is just some quick instruction on how to fill out the notes page on the Venn diagrams and gives you a little bit of reminder of what Venn diagrams are. So we use them just to show relationships, and the three different types of diagrams are shown here. So the first one on the left is a circle inside a circle, and the symbol that we used for that type is P implies Q. So P implies Q means that if you have something in set P, then that also means that it's part of set Q. All right, in the center one, we have two overlapping circles. So if we had shaded in all of P and all of Q, that would be P or Q. So that's both circles, as this indicates that everything is included in P or Q. But then in this area right here, the overlap, that is P and Q. So when we have P and Q, we don't have nearly as much of a space. So the P or Q would be all of it colored in. The P and Q would just be this center area colored in. Okay, because P and Q implies this overlapped region, so it has to be part of both the P set as well as the Q set. P or Q just implies that it has to be in one or the other, so all of P and all of Q would be considered. And then the last diagram is P does not have anything to do with Q. There's no relationship whatsoever. So how do we implement these? Well, it's just, remember, the Venn diagram is just a visual representation of data and relationships. So when we have number 1, it says some students who take chorus also take band. We would represent that by 2 overlapping circles, because some students take chorus or they take band. Sorry, I'm not printing very well. Number 2, no perfect squares are prime numbers. So there is no overlap, and so this would be the perfect squares, and this would be prime numbers. Number 3 shows numbers divisible by 6 are always divisible by 3. Now these are the tricky ones because we don't always remember what goes inside. So numbers divisible by 6 are always divisible by 3. So the one thing that's always true about the other is that divisible by 6 would be the subset inside divisible by 3. And we can check that if it's necessary. You want to check that just to say, so let's think of a number that's divisible by 6, like 18. 18 is also divisible by 3. Let's think of a number that's divisible by 3 that might not be divisible by 6, 27. So 27 is divisible by 3, but 27 is not divisible by 6. So that means 27 would be a number that's in this big circle, but not in this little circle. But everything in the little circle also satisfies the fact that it's divisible by 3. Okay, number 4, every natural number is a whole number. Again, this is a circle inside a circle because we have the word every. So we have to decide what goes inside the little one and then inside the larger one. So every natural number is a whole number. So that word every tells us that we need to put natural number here, and whole number goes out here. And if you think about what the natural numbers are, they're the counting numbers, 1, 2, 3, 4, 5. So all the positive integers except for 0. The whole numbers are all natural numbers, including 0. So whole numbers is slightly bigger set than the natural numbers. Number 5, some vertical angles are complementary. Some implies an overlap, so we would overlap those. So we'd have vertical angles and complementary angles. All right, number 6, irrational numbers are never rational numbers. So here we would have two circles not overlapping, and we'd have irrational and rational. Here we have to start shading to indicate what this symbol means. So here we're saying that we want all of all of Q. So all of Q means we're going to shade in this entire Q circle. So all of that is shaded in. And number 8, this symbol means P and Q. So that's just the overlap. So it has to hold that this is in P as well as in Q. And that's the only region that that is true. In number 9, we have P or Q. And as I had mentioned before, whenever we have P or Q, it's everything in P or anything in Q. So that ends up filling in the whole entire circle, both circles. Now number 10 is an interesting one. So P and not Q. So we know we're going to fill in P, but we can't fill in Q because it says not Q. So Q, everything over here in Q cannot be part of the set. So we can only fill in this part of these overlapping circles. Here are the explanations for each one of these. So here, because we have a circle inside a circle, it implies all all angles that measure 60 degrees implies that they are acute angles. So we can write that. All angles that measure 60 degrees are acute. All beagles are dogs, because the beagles, every beagle is going to be inside this little circle, which is included in this bigger circle of dogs. Number 13, students who play piano and take volleyball and take piano lessons, So this is an and because it's colored in on the overlap. So it's only those students that do both. So that and section of the overlap. Now number 14 is one of those confusing ones because we're only taking this circle but none of this circle. So months with 31 days, which is this whole circle here, and do not start with J. So we have to take the months that start with J away from this circle. So that's why this little wedge is not colored in, because we're not taking any of J. Now 15 is similar, only this time we're taking the freshmen who are not in art class. So all the freshmen are all this circle, but we have to remove from this the ones that are in art class. So when you look at this circle of freshmen, we're just removing the section here that is the overlap with art class. Okay, so number 16 is the last one on this. And here, because both circles are completely covered in, we're taking all of the things, so it can either be part of multiples of 7 or even numbers. And that would include everything in this diagram. So that takes care of this particular notes page, but I think we need to do a little bit of practice on some analyzing numbers and identifying quantities according to all of these rules and in the information that we just discovered on this notes page. So you can look for another video on interpreting Venn diagrams.